And just building on the comments of the speaker before, that this mustn't be the decade for debate and that we're going to have to see a big shift in behavior, particularly in industry at scale. Lucky for you, this panel is made up of people that are moving at speed, that are starting to work out what they're going to deploy and how to make good use of technologies and collaborations at their disposal. So we'll be digging into that. So in no clear order, my fault, I should have thought about where everyone sat, but I'll start with some introductions. Nick Windsor, in hot seat number 2, is the UK government's Electricity Network Commissioner, Commissioner for National Infrastructure, and the chair of the Energy Systems Catapult. He brings extensive experience from a very systemic background, which we're very pleased to have on this panel. 30-year career in the energy sector, which includes being CEO of National Grid in the UK and Europe, president of the European Network of Transmission System Operators, and much, much more. Last year, Nick was appointed as the government's Electricity Networks Commissioner to accelerate the delivery of crucial network infrastructure and obviously fundamental to our discussion today. Dr. Chris Manson-Whitten, CEO of Progressive Energy. For those of you that follow industrial decarbonisation, you'll know Progressive Energy is not only at the forefront of HyNet, but also recently announced the Peak District Cluster, Peak Cluster. So a very well-respected industry leader and low-carbon energy expert. Yeah, I'm sure we'll dig a lot more into both your experience and what you're up to, Chris. Ian Livingston is a project manager for the Humber cluster from Equinor. Equinor obviously focused on all sorts of activities, but a significant presence in low carbon engineering and projects. And obviously Ian's focus is on the Humber region, where he coordinates Equinor's industrial decarbonisation challenge activities for zero carbon Humber. So a second key cluster for what the UK is aiming to deliver. And last but definitely not least, Jenny Sutcliffe, who's principal consultant for regulatory affairs for the Phillips 66 Humber refinery. So I'll tell you a little bit more about Jenny, but what's interesting about this is you can see that what we have is systems people, cluster people, and also site kind of leaders so that we can really talk about what's needed to decarbonize those energy inputs. Jenny is part of the decarbonisation team at the refinery with a focus on HSE, regulatory and government issues, specifically around carbon reduction projects and initiatives. Yeah, Jenny, I'll let you tell a little bit more because we're going to kick off this panel with just very brief, kind of descriptions really about the perspective that each of our panelists bring to this. And the theme today for this specific panel is about the inputs into industry. So we're going to be talking about clean energy and the things that come into industry. And there's a subsequent panel afterwards that will look more at the operational decarbonisation and emissions capture with CCS. So we're looking at the front end, if you like, of decarbonisation. Nick, can I ask you to start?
Should we stand up?
If you can stay there.
Okay. Okay, good morning, everybody. Thank you very much for the invitation to come and talk to you about this topic. I'm speaking primarily on behalf of the National Infrastructure Commission today. We'll be producing our second National Infrastructure Assessment in the autumn of this year. It's a 5-yearly production, and we'll be talking about flexibility of the system in particular, solutions for heat, but significantly for today's panel, major network infrastructure. And the focus for today is about industry, although of course we should reflect that the networks need to be built to enable the whole of the energy system to work together. So what do we know? We know that we're going to need more electricity capacity in our networks. My own work for government, with a report to be delivered in the next few weeks to government on accelerating transmission build, plays to that. That will be significant in itself for the transition of a lot of industry over to electricity. We know that we're going to need to move some hydrogen around. In my personal view, it's unlikely this is for domestic heating and domestic use, but certainly for industry. The Infrastructure Commission will, in the autumn, be talking about hydrogen networks. They'll be important, particularly, I believe, for elements of industry that need to produce heat, chemicals, iron and steel, ceramics. We know there's also parts of industry that will not be able to replace their fossil fuel usage with hydrogen, and they'll need CCS. These are processes like cement and lime, petroleum, energy from waste. We know that this is where CO2 comes from the process itself, and therefore needs to have carbon capture and cannot be just displaced by changing from fossil fuel burning to something like hydrogen. So we have three networks in play here. We have increasing the electricity network, we have creating a hydrogen network and a carbon dioxide network. We know, so where are we going to build this stuff? The electricity stuff is well planned and difficult to deliver. I'll be talking about that subsequently to this day. But the critical things are where to build our carbon dioxide networks and our hydrogen networks. We obviously can start by looking at clusters. And it seems to me likely that clusters, and our speakers will talk to this, will need to be connected to CO2 networks and hydrogen networks. That's a starting position. But we also know there's quite a lot of CO2 production which isn't in clusters, particularly cement, lime production, amongst others, things like energy from waste. So a key question is, are we going to move those into clusters, or are we going to provide very significant new networks to point positions on the map? Once we've decided, which the Commission will be talking about in the autumn, where our initial carbon dioxide and hydrogen networks should be built, it's not just engineering, it's about a whole regulatory, political and business framework to allow investment to flow into there, to allow communities to understand why these new networks are being built. Thank you.
Great. Thanks, Chris. We'll come back with some specific questions and dig into more of that. Chris, could you give us your bird's eye view?
Sure. Forgive me, I'm going to stand up so I can see everybody. Can you hear me yet? Yes. Wonderful. So, yeah, I'm from Progressive Energy. Our mission is to take material quantities of CO2 out of our energy system. And to do that, we do it in two ways. One is to build consortium and partner. And secondly is to focus on industrial clusters. So we're part of HyNet. We initiated it, but we now have a set of partners, and in particular, any who are providing the underlying CO2 infrastructure, which is for transport and storage of the CO2. And they, under the cluster sequencing process, are now the lead of that project. So we're really pleased to be able to do that. Let me tell you a bit about HyNet. One, it has infrastructure. It has CO2 infrastructure, hydrogen infrastructure, both transport and storage. But importantly, it is demand-led. Demand-led in two ways. One, by a host of industrial users that wish to transition to low-carbon hydrogen, whether that's Unilever, Pilkington, Tata Chemicals, many others. I'll talk about them a bit in a moment. And others for whom they inevitably emit CO2. If I make cement, yes, I can fuel switch a third of my emissions away, 2/3, I can only capture that CO2. And cement, globally, makes up 7% of our global emissions. It is a big sector. So that's the users of the network. To tell you a little bit more about the network, so yes, grounded on storage in Liverpool Bay by Eni, so 200 million tonnes of storage capacity with an onshore pipeline, going to a large-scale CCUS-enabled hydrogen facility. So we're partnered with the refinery up there as Vertex. We have the first gigawatt under development, the first 350 megawatts already selected into the negotiation process under phase 2 with government. But we have electrolytic projects also being developed. We're in partnership with Foresight and Statkraft building that. Connecting to around 100 kilometers, just over 100 kilometers of hydrogen distribution being delivered by Cadent, and then connecting to storage. We will have 1,300 gigawatt hours of storage of hydrogen in the geology up in the northwest. That is equivalent to the entire UK passenger vehicle park, 30 million vehicles converting to an EV, say it's a Nissan Leaf at 40 kilowatt hours, that is still less storage than we will have of hydrogen up in the northwest. So together that brings the infrastructure, and I normally have a video at this point. Let me paint one simple narrative for you. I'm looking forward to the point when I can jump into my Jaguar Land Rover, which is a net zero vehicle made with recycled aluminium from Novelis using low carbon hydrogen, drive back to my apartment built with low carbon cement from Hanson. I can then go up there, grab my rubbish, take it out, knowing that the residual will be used by Viridor after recycling and the CO2 captured, come back, wash my hands with a product from Unilever, grab a beer from the fridge made by Heineken, low carbon hydrogen, bottled by NSERC in a low carbon bottle, and look out over the Liverpool skyline through glass made by Pilkington using low carbon hydrogen. That can happen. We need to make it happen. Thank you.
Thanks, Chris. I think based on that alone, you should run for something. I'm going to vote. Ian, could you tell us a bit more about your work on the East Coast?
Yeah, no. Am I on? There we go. Okay, so my name's Ian Livingston. I work for Equinor's Low Carbon Solutions business unit. So I'll just start with a little bit about Equinor, and then we'll dive into the Humber cluster a little bit more. So Equinor are a developer of carbon capture and storage, transport and storage, and capture projects, as well as low carbon hydrogen production, both electrolytic and CO2 enabled. So in the Humber region, we are the lead partner for something called Zero Carbon Humber, which is one of the sister deployment projects under the Industrial Decarbonisation Challenge to HyNet, and one of 2 deployment projects in the Humber alongside Humber Zero, which Jenny will talk about, I'm sure. So Zero Carbon Humber is a grouping of 14 industrial partners in the Humber region, representing a range of people who've got existing assets in the Humber region to decarbonise, or inward investors looking to create low carbon hydrogen or provide infrastructure for transport and storage of CO2 as an example. So much like HyNet, really high energy intensive cluster, perhaps slightly differently becoming a demand-led cluster, but perhaps started with hydrogen producers really kind of selling that hydrogen in terms of its virtues and particularly its benefits in use of industry for decarbonising heat. So if I focus on our H2H Salt End project, which is Equinor's flagship blue hydrogen production at the Salt End Chemicals Park, we work with a range of customers to decarbonise their energy inputs in a couple of ways. So the primary way is by enabling those natural gas users to fuel switch to low carbon hydrogen produced at the chemicals park. And then there's a secondary impact whereby we provide hydrogen to an on-site power station to decarbonise power production and also steam production used by all of the users of the chemicals park. So a Salt End Chemicals Park user gets decarbonisation through fuel switching natural gas, small decarbonisation of their power stream from the power station, and a degree of decarbonisation of their steam stream through decarbonisation of the power station. So you end up with this kind of compound effect of decarbonisation because of the integration of the heat and power networks at the chemicals park. So really important, and today's panel obviously focused on decarbonising energy inputs. I suppose our Salt End project kind of mirrors that 100% really. We're looking to take away the carbon in as many of those energy inputs to the manufacturing processes as possible. Also in the region, we're working with a number of partners on post-combustion power stations, so looking at taking carbon out of the power system, as well as developing the world's first 100% large-scale hydrogen power station with our partners SSE at Keadby. So really focused on providing low-carbon electricity for use in the region, but also in the national transmission system. And to enable that, we need this transport and storage infrastructure, particularly for hydrogen. So much like HyNet, Zero Carbon Humber, the Humber cluster has hydrogen storage being developed at significant scale by Equinor and partners SSE at the Aldborough natural gas storage facility. So a really similar model to HyNet, where an existing natural gas storage provider with experience is looking at transitioning their assets to the energy transition. I'll leave it there. Thank you.
Thanks, Ian. And Jenny?
Thank you. I work at the Humber Refinery, which has been in operation in North Lincolnshire for more than 50 years, making fuels and petrochemical products. It also makes something really important, graphite coke, which has traditionally been used for the aluminium and steel recycling industries, but is also now a really important component of lithium-ion batteries. Those lithium-ion batteries are used widely in consumer electronics and electric vehicles, so actually a really important product for decarbonising transport and the energy transition. We're also a leader in producing renewable fuels and are the UK's only producer of sustainable aviation fuel at this time. So we believe that these products are going to be really, really essential going forward, along with the other products that we make. So how do we decarbonise what has traditionally been a very energy-intensive industry? We have developed plans to become a refinery of the future, looking at our Scope 1 emissions and Scope 2 emissions and Scope 3 emissions, such that we can do that, lower the carbon footprint of what we do, so we can still provide those products, but in a lower carbon intensity way.
Brilliant. Okay, so that's our kick-off point and a bit of an explanation about the viewpoint that our panelists are coming from. Let's start with a kind of question to everybody and just a relatively speedy answer on this. The emphasis of news stories, I mean, if all you did was read the news to find out what was happening in industrial decarbonisation, you'd think probably that carbon capture was the main game in town. And I'm just wondering, to what extent do each of you feel like, do we have enough focus, enough discussion, enough kind of that very top level public discussion about the need for industrial scale clean energy? Yes or no? And I'm going to start with you, Chris.
Go on, thank you. So to industrially decarbonise, we need low carbon electricity, low carbon hydrogen and capture plant. If you take a glassworks, take NSERC, ultimately they want all three because different parts of their process do. So yes, I think we do need them all, we do need the emphasis, but I think by talking about the products that consumers use, we make it alive to the consumers about how we decarbonise.
Okay, thank you. Nick, I'm not ignoring you. I'm going to come to you last because I have a second follow-up question for you. Jenny, thoughts on that question for you? Like, are we emphasising enough the need for industrial scale clean energy?
I think we are, yes. I think that you have to decarbonise the various different sectors, and power generation, of course, is one of the major sectors that we need to decarbonise. The UK is a leader in offshore wind production, so we need to continue that and looking at other ways for renewable sources to decarbonise our electricity infrastructure. There's still an argument that we'll never get away from gas-fired power generation, and so for those facilities that still needs carbon capture to decarbonise gas-fired power. So it does need all of it. It needs a balance.
Okay. Ian?
Yeah, completely agree. So decarbonising the energy inputs, if you like, the power system is so important, not just for industry, but for the rest of society, right? So as we start to electrify more and more across society, heat pumps, EVs, etc., the early decarbonisation of industrial energy acts as a kind of a catalyst to decarbonise the rest of the power system, and certainly with government's targets of having the net zero power system by 2035, that's only achievable with all of the things that we've talked about, kind of electrolytic hydrogen, blue hydrogen, CCS enabled power, as well as the infrastructure that's needed to make all of that work in an integrated fashion. So yeah.
Okay. Then Nick, I've got a sneaky follow-up for you anyway, but what are your thoughts on that question?
Well, I'm going to interpret your question slightly differently. The answer is no. No, we're not discussing this stuff enough. And it depends who you think we are in that sentence. Well, we're discussing it quite a bit. Are the public discussing it? Could we expect them to? Probably not in the detail we would. But the truth is that we are going to have to make very substantial investments in new infrastructure, new linear infrastructure across our country. And it's going to affect people, it's going to affect communities, there are going to be implications for the whole of society. We actually need to be out there much more vocally talking about our plan for what it would take to decarbonise our economy, set the context for people before we turn up in their communities and say, actually, we need to build some linear infrastructure, you know, past your village or close to a treasured landscape, because they need to understand the context, and we need to inspire the public in this journey.
Yeah, we run an American event, and one of the US project developers was talking about how much time they're putting into communicating plans, even at school, high school, and university levels. So it's not just at the kind of taxpayer community level, like really putting time into educating their kind of communities and the groups that they're going to be affecting with what they're doing. So I think I oversold it by saying it was a sneaky follow-up. It's definitely not a sneaky follow-up. But tell us a bit, because in this room, there will be people that fully understand the hydrogen value chain and all it implies, and then many who probably don't. So how does hydrogen, or how will it fit into the existing energy system, and what requirements does that place, you know, with your systems brain on, what does that mean?
Well, from a systems point of view, we first have to decide what we're likely to use it for. It seems a very, very valuable opportunity to decarbonise, particularly the heat elements of a significant amount of industries. There's quite a lot of talk about it being used for heavy transport, and of course the debate rages and rages about whether it'll be used for domestic heating, or whether a better option is heat pumps. So we sort of have to make some calls on that. It seems very strong in the first two of those, and a more questionable proposition in homes. And we have to make that call because whilst it's possible to imagine some green hydrogen production in the clusters, and therefore you wouldn't need networks for that, if you want to use it more broadly than the clusters, or potentially create green hydrogen where we've got an excess of wind power, say off the north of Scotland, and ship hydrogen south, or store it and use it for power generation when it's not windy, then you need some networks. So we have to make some fast calls on those things.
And kind of ballpark level of investment? What would you imagine we're talking about to kind of deploy infrastructure?
Well, in networks, I think at the moment my expectation is we would need some transmission level networks and not domestic piping, and so, you know, a small number of billions.
Okay. Chris, tell us a little bit more about, you've mentioned some of the well-known brand names that are within the HyNet cluster, but what's the energy requirement that they are bringing to you? So when we start talking about the need for hydrogen, green hydrogen, the need for other forms of clean energy, just what are we talking about there? What's the amount?
Okay, yeah, so numbers are really important. So our vision within HyNet at the moment is to ultimately to have 4 gigawatts of hydrogen production. That would equate to around 30 terawatt hours of hydrogen. In our region, that would make up about 50% of the natural gas which is flowing around the region. A big chunk of that is industrials, but actually the other really, really big, and actually will dominate ultimately, is that dispatchable power. So what have fossil fuels done for us for 150 years? They allow us to bunker energy. You cannot bunker electrons at that volume, and in order to decarbonise our electricity grid by 2035, we will need a way of doing that. Yes, some batteries, but at grid scale, I've made my point. I strongly believe we can have hydrogen produced when it is appropriate, either baseload from CCUS enabled or from wind and solar, store it and then use it, and then maybe a role too for some post-combustion capture. But that's where the energy flows are in our region, and if you think our region as maybe a tenth of the UK, that gives you a kind of overall scale.
Okay. And Ian, can I come to you again? If you're able to put a number on the demand, that's kind of helpful, I think, for just imagining the task ahead.
Yeah, well, maybe I'll take a slightly different view to Chris and maybe zoom in just a little bit and talk about maybe some individual off-takers just to give you a flavour for sort of size and scale. So, as an example, our Saltend hydrogen production project, H2H Saltend, sized at around 600 megawatts of hydrogen production. And we've got somewhere around 6 or 7 off-takers that we're talking to for that sort of volume of hydrogen. So some ranging from quite small demand in industrial terms, in terms of 10 to maybe 20 megawatts, and then others up to maybe 200, 300 megawatts potentially. So, you know, really sort of, when you then zoom that out across the whole region, you're sort of aggregating tens, 20s, hundreds of megawatts to get to the sort of numbers that Chris is talking about. So you're talking about a serious number of customers, and then we come back to the infrastructure point. You know, we're quite lucky with the Saltend Chemicals Park, and I'm guessing Vertex in Hainaut is the same, where the initial grouping of customers are very close to the production site. So there isn't really an immediate need for transport solutions to connect production to demand. But as we start to grow that hydrogen production outside of those early centres, transportation solutions are absolutely critical. And realistically, we're talking pipeline infrastructure. And at the moment, certainly in our opinion, government are a little bit behind in terms of supporting the development of hydrogen transport infrastructure. Business models, as an example, really not being talked about being in place until 2025. So if we're to try and get to some of the hydrogen targets that government has, ambitions, they're now calling them, not targets, right? So 10 gigawatts of low carbon hydrogen by 2030, if we don't have hydrogen transport infrastructure in development, we're never going to be able to get to those targets, because you won't be able to connect 10 gigawatts of production to 10 gigawatts of demand, and nobody's going to build 10 gigawatts of production unless they've got customers to take it.
Okay. We're going to come back to heckling the UK government. I have a question on that, don't worry.
Good.
Jenny, so as someone who's kind of in a refinery team looking at clean energy requirements, how are you going to look to source? What are you going to look to source, and when do you need to source it by, with your target or ambition in mind?
So a lot of the energy input to a refinery comes from fuel. And we can decarbonise that either by switching the fuel for hydrogen or for capturing the emissions from that fuel, so hydrogen or carbon capture. Carbon capture can also be used on the refinery for some of the processes which generate CO2, not as a result of fuel combustion. But we also have electricity and steam inputs. Those come from a neighbouring combined heat and power plant, which is owned and operated by VPI, and that is a gas-fired CHP. It's already a very energy-efficient setup, because not all gas-fired also has that combined heat and power element to it. So it already is industrially a very kind of interlinked and complex and efficient setup. But they are our collaborators in a project for carbon capture called Humber Zero, which is based in the Immingham area of the Humber region. So again, they decarbonise their energy supply to us through carbon capture of emissions or hydrogen fuel supply to that power plant. So it does keep coming back to those same themes. And importantly, of course, those projects are very large scale and they cost. So you need the government business models to underpin those projects, to get them deployed, to get them at scale, and to make them more efficient and cost efficient, and so on, get these networks established. So those are the main ways in which the refinery can decarbonise its power source. Of course, energy efficiency again. So energy is the second biggest cost to the refinery as it is. We are incentivized to drive it down, both for environmental performance, but also for costs. But that really only gets you so far. So decarbonising the actual emissions from the power supplies, from the energy supplies, is really the main issue.
Is there, I mean, this may be an idiotic question, I don't know, but is there a deadline by which all power coming into that kind of site structure will be clean, or is it, are we not, I don't know, do we have a dateline for something like that?
Well, the deadline is net zero by 2050, I think. So working with the government and with the industry networks within the Humber region to try and achieve that, and their interim targets, the interim carbon budgets, is what we're working to.
Okay. Nick, I'm going to come back to you. So we've talked a little bit about clusters. We've talked about site-based, which is also part of a cluster. What, again, I keep referring to you as the systems person on the panel, but what's your view about what's going to be needed beyond clusters? When you and I did our prep call for this panel, you were talking about, obviously at the moment the emphasis of conversation does tend to be cluster-based, but there's a lot of industry that sits outside natural clusters. What's going to be needed to retain that, do you think?
Well, I think there's some difficult decisions ahead. I mean, we've been looking a bit at the different types of industry which are outside clusters, particularly cement works tend to be around sorts of the minerals they use. I walked past the cement works at Shap the other day, and I was thinking, that's not really in a cluster, is it? So we need to think about some of those things. It seems quite a hard proposition to build networks, CO2 networks out to individual sites like that. Could you form a cluster there? Very possibly. I think clusters are an incredibly valuable way of thinking about the transition, working out from clusters. And I think once you've got clusters, you can start to think about energy from waste as well. There's emissions. We all thought that it was great to burn waste and the emissions that come from that, but it's very distributed. So we've got a lot of CO2, distributed CO2 being formed. So we need to think about whether we're either going to move our waste or have CO2 networks from our energy from waste plants. Once you've come up with this sort of topology, of course, what then follows is you can start to think about, once you've got a network, well, where are we going to put our greenhouse gas removal technologies? Looks like clusters would be a good place for that, or new clusters. And of course, as the other speakers referred to, you would then probably think that any electricity generation that may well either be based on burning hydrogen or burning still gas but collecting the CO2, well, starts to look very attractive from a network point of view to put those near clusters as well. So there's a sort of logic to how you plan this set of networks.
Okay. I am going to move to questions in Slido in a moment, so if you want to put anything in there, we've had our first view, please do. A kind of a bit of a yes/no question for the panel, and maybe give a qualifying answer. Are you confident that we are going to have enough green hydrogen by the time we need it in order to decarbonise, along with your, either to government targets or to industrial partners' targets? Chris?
I'll kick in. You said green. Can I say low carbon hydrogen?
You may.
So I think it is really where we are at the moment. Look at our energy system. We have world leading offshore wind, about second in the world, 30 to 35 terawatt hours of energy per annum. Sounds a lot, growing by 5 times. Our total energy demand is 1,730 terawatt hours. We can't just rely on green now, so we need the blue, but by the time we get to 2040, 2050, the green will dominate and then it'll work. But it can't be green only now, I'm afraid.
Nick?
It is a real challenge, as people say in these sorts of situations. Because electricity demand is in itself going to increase sharply with decarbonisation of heat and transport. So whilst we're really making fantastic progress with deploying, in particular, offshore wind, we're chasing a curve that's going upwards. So then to have to get ahead of that curve and therefore produce incremental amounts of green electricity to generate green hydrogen, we're going to have to go very, very fast. And that's the challenge. You need to do sort of detailed modelling of what might be done Personally, I'm nervous about non-green hydrogen development. I fear the emissions will become embedded in our system. I fear that once we go that route, we give ourselves a slightly too easy path that we can't afford. So I think one of the mitigations for that is if you heavily do the heat transition on domestic heat transition on heat pumps, then you're only needing to produce green hydrogen for industry and some transport, which I think is its best use.
Okay. Jenny?
I think you phrased it as to get to what needs to be done. That's quite general. So I'm not sure, but the government targets, I agree, are ambitious. Phillips 66 have been developing a green hydrogen project with Ørsted called the Gigastack project. And again, the targets are very ambitious for the deployment timeframes that the government are after. Does that get us to where we need to go in terms of net zero? Again, it's just all about how quickly can we do it. So we need to deploy these things as rapidly as we can and learn about them, grow those industries. We need to get these foundation projects in. We need to build the networks and get them growing as fast as we can. But it's definitely going to be a challenge.
Okay.
Yeah, I'll maybe take a slightly different viewpoint and talk a little bit about infrastructure, right? So if you do want to get to the government's ambition of 5 gigawatts of electrolytic hydrogen by 2030, electrolytic hydrogen at that scale doesn't work without hydrogen storage. Hydrogen storage doesn't work without hydrogen transport systems to connect it, production to demand. And if you think about the life of a hydrogen storage project and how long these things take to build, we're already at a point where government business models for hydrogen storage are probably not going to be in place until 2025. Some hydrogen storage sites probably take 5 to 6 years from financial investment decision, if not longer, to get to commissioning and build. And all of a sudden we're in 2031, 32, and it becomes very, very difficult. So for us in the Humber, we've got a gigawatt scale green hydrogen project in development with our partners SSE, where we're looking at the final phase of the Doggerbank D wind farm being produced exclusively as green hydrogen, but that's fully integrated with a hydrogen storage project because there are no customers for hydrogen out there that are willing to take hydrogen only when the wind blows. So there's some enablers that are required, I think, if we are to get to those ambitions.
Okay.
Could I be really blunt and just add to that? I completely agree with you, Ian. You have projects, we have projects that are going to go on ice for 2.5 years if we wait till the end of 2025. There needs to be some interim enabling that government provides to keep those projects live. And to be honest, projects don't survive going on ice. So this is serious. We need a solution that bridges us to those business models. Yeah. Absolutely vital.
Okay. All right, we're going to take some of the audience questions. I'm going to ask raise your hand if you think you've got an answer. I think that's the best way to do this because we won't ask everyone for their view on everything. So I have a bit of a view on this one, but is burning hydrogen the best solution to decarbonising industrial heat demand? Anyone here, or can I have a bit of a step? Jenny?
Yes, quite frankly, that is one of the best solutions for decarbonising industrial heat demand. At the moment, what's being used is natural gas or equivalents to natural gas. So hydrogen, of course, decarbonises that. The government is incentivising the hydrogen production to be low carbon through either the electrolytic or the blue hydrogen. So, of course, you need to make sure that hydrogen is a lower carbon source. But yes, as a key heat input to the process, that's one of the main ones.
Yeah, the little bit of knowledge I have on this is more from the startup end of things. So I know there are some really interesting startups. We had one on the podcast recently called Airthium, who are starting to explore how temperatures of up to, say, 500 degrees could be offered through steam and heat through their heat pumps. But we're a way off the kind of high industrial heats that most industrials rely on, but still interesting tech to keep an eye on.
Yeah, and I'd add, if I can, that I think industry really is key to unlocking large-scale hydrogen demand, because you've got a lot of small modules in production being used at fueling stations and things around the country, but a large-scale industrial demand will guarantee that offtake for some of these large-scale hydrogen projects, which in turn makes them more cost-effective, and so on. So really, industry for hydrogen demand is probably one of the key stepping stones that we need to grow hydrogen production.
Next question is one that, yeah, I hear this from my friends, let alone from the grown-ups in the world, but how do we explain to the general public the need for CCS, hydrogen, gas-fired power, nuclear power, oil products, all sorts of fuel sources needed throughout the energy transition? Yeah, any takers for that? Can we persuade the public, Ian?
I think it's our biggest job, actually, right? So, and in some respects, this is why we start with industry, because you can get this stuff going and be able to demonstrate its safe, responsible use in industry first before some of those end-use markets that are closer to the general public. Might not be heat, but it might be transport or other uses. And, you know, certainly there's a language and a lexicon thing, right? So we're here talking about decarbonisation. We ran a kind of a large public engagement workshop in the Humber. We got about halfway through that workshop before one of the attendees kind of put their hands up and kind of very bravely sort of said, can somebody just tell me what decarbonisation means? Right, and to us, it's perfectly normal.
Yeah.
To general public, they think about climate change, they think about weather impacts, but they don't necessarily use the same language that we all use in this industry. So one of the things we're trying to do is to sort of get into schools, primary schools, early secondary schools, to just start the kind of normalization of these things in language, and that kind of filters through to what we call like dinner table conversations. So a child goes home from school and, you know, just enables some conversations in general society, and the more we use the words carbon capture and storage, hydrogen, the more it kind of filters through and people get interested.
Nick, you have a view?
Well, we just have to. This is an enormous transition for society. It's going to affect everybody's lives, and we just have to face up to that, and we have to explain it to society, to individuals, to communities, in a very. We have to be very respectful, and being respectful means that we have to put an awful lot of work into it to do it well, and it won't be easy, but it's absolutely critical to the transition.
So I would say we are all consumers. We make decisions every day. So a company like Diageo, the biggest drinks manufacturer in the world, has said its drinks need to be low carbon. It wants low carbon whiskey. But then it turned around to Ensert, the largest bottling plant in Europe, which is in the northwest, and said, we need a low carbon bottle to put the low carbon whiskey in. The idea is then there is a product on the shelf which is then low carbon. Now, I know we need to get rid of greenwashing. We need all the tracking through there, but that starts to make it an everyday choice for people to choose to be low carbon. And then you get exactly the conversations we've just talked about.
I'm going to come to Jenny with a different question from the audience, just because you are here to represent an industrial emitter. As an industrial carbon emitter, what am I supposed to do if I'm not in or near a cluster? So if that were your scenario, what would you be doing this week, this month, and in the medium term to try and affect change?
Oh, yeah, I mean, that's quite difficult because obviously I am in a cluster. But, I mean, you've got to, again, look at the energy sources. Depending on the size and scale, I think is another thing. If you can easily convert to hydrogen through like hydrogen modules or hydrogen boilers or heat pumps or lower carbon electricity sources, then I think all of those are important things. I think a lot of the clusters now so some of them are sort of kind of industrial clusters. For example, the Black Country, I'm thinking, is a very large industrial cluster that's covering literally hundreds and hundreds of emitters, and they're all smaller scale businesses. So I'd maybe look to them and see what are they doing about that, because that's a lot less about the hydrogen and carbon capture networks and much more about how do you get it to some of the not industrial scale but still large manufacturing processes. So there is a lot of information out there that can help with that.
Yeah, I think amongst our members there are a couple of interesting collaborations emerging for industrials that are they're just not near that kind of cluster-based infrastructure, but who are either co-investing in kind of new tech projects together as a means of sort of starting the ball rolling, or just really focusing on their own circularity, waste heat recovery, those kind of projects, which, you know, that's not going to get them to net zero, but it gets them on the path until perhaps other answers become more obvious.
And there are some intermediary satellites to clusters. So to Nick's point about that cement works, Peak Cluster is doing just that, bringing together 40% of the UK's cement emissions located, because the geology dictates that you've got your feedstock in the middle of the Peak District. Right, provide a pipeline to bring that out and then take it out to as a satellite to an existing cluster. So last question, and then we'll need to wrap up. I mentioned earlier, you know, that we'd have our chance to heckle or to whatever. Obviously, the UK government, along with governments elsewhere, have put together their own mix of incentives, policies, and other things to support decarbonisation. Just a very brief answer on this, please. But what's the one thing on your wish list that the UK government could be doing now? Maybe it's this transition period rather than projects on ice. The one thing that you really wish was coming into being now. Chris? I have to say it is transport and storage of hydrogen. It will de-risk, it will bring costs down, it will bring more competition, and it will enable infrastructure. We've got to solve that 2.5-year gap.
Nick?
I would say strategic planning of the system so that we can identify network choices as early as possible.
Okay.
So for me, it's carbon capture and storage, because that targets both power sectors, power aspects of power that are difficult to decarbonise, but it also targets the industry that can't decarbonise, like some of the process that we have on the refinery, like cement and glass. They obviously are on the pathway. I think they are doing the right things, but I'm going to say something you'll hear a lot, which is speed. It's not just speed. I know they're going as fast as they can, but I think we have a tendency to overthink. We want to have all of the answers. We want to have made the best decision that we possibly can. And I think perhaps the perfect is being the enemy of the good in these situations. These are new industries. We've got to get on with it. There's going to be a steep learning curve, so we've got to get on with it, get some of these things deployed, and start learning.
Okay. Ian, do you want to close us out?
Yeah, I suppose for me it's a very specific call and a very specific ask, and echoes Chris and Jenny's points, really. So for me, it's about infrastructure, and the hydrogen transport and storage is absolutely important. But at the moment, what we really need is the next phases of the CCUS cluster sequencing process, both track 1 extension and track 2, to come forward as quickly as possible, at least some details, so that we can all plan against those things, provide our investors and our internal boards confidence that UK really is going to deliver on their aspirations and targets.
Great.
Absolutely.
Well, thank you. Thank you to all of you who put questions in. I'm sorry we couldn't get to all of them, but I hope you found it useful. Thank you to each of my panelists for a great discussion.
Thank you.